You are welcome to the GMAETS 41's live stream class. We are going to deal with something wonderful in this particular live stream section. Once again, you are welcome. And I hope the GMAETS 41's dear friends are really having their wonderful times with their ongoing examinations. In this particular class, we are going to give attention to how to deal with titration question that is focused on the concept of percentage purity. The concept of what? Percentage purity. All right. So if you can hear me once you join the class, please, you can type I can hear you. Okay, you can type that. All right. In our previous class under titration work, remember that I taught you how to determine the mass, that's the molar mass, the molar mass of an unknown base, monobasic acid. Yeah, remember that. Then told you that I would definitely host a class where I would teach you how you can carry out calculations on percentage purity and, of course, water of crystallization. So please, dear friends that have joined the class, if you can hear me, kindly type I can hear so that together we can kick off the class. If you can hear me, please do kindly type I can hear. All right, so that I will kick off the class. You're welcome to the class, those that have joined. Please type I can hear so that I will kick off the class immediately. Okay, that's good. Thank you for indicating that you can hear. All right, so as usual, we are going to look at this question. All right, Kelmi, you're welcome. Onyinye, blessing, you're welcome. So let's get to business now, okay? We shall be looking at this question. It's an exam-related question on titration. And the focus of this question is to help us learn how to calculate percentage purity. So I've got this question, and as usual, I will dictate it. Follow along as I dictate this question, okay? You might write it down. And this is the question. A is 0.100 mole per dm cube HCl. A, capital letter A, is 0.100 mole per dm cube HCl. B contains 6.0 gram of a mixture of anhydrous sodium carbonate and sodium chloride in 1 dm cube solution. B contains 6.0 gram of a mixture of anhydrous sodium carbonate and sodium chloride in 1 dm cube solution. 25 cubic centimeter portion of B required an average of 22.65 cubic cm of A for complete neutralization. 25 cm cube portions of B required an average of 22.65 cm cube of A for complete neutralization. Calculate the I, molarity of Na2CO3, that is sodium carbonate, sodium trioxocarbonate 4, NaCO3. we have to calculate the molarity. II, mass concentration of Na2CO3. Mass concentration of Na2CO3 in 250 cm3 in 250 cubic cm, that's cm cube of B. I read that again, II, question II. You have to calculate mass concentration of sodium trisulcarbonate 4, that is Na2CO3, in 250 cm cube of B. II. The third part of the question, percentage by mass of sodium chloride in the mixture. Percentage by mass of sodium chloride in the mixture. Then below we have in brackets H equal to 1, C equal to 12. That's the relative atomic mass of this element in the compound. The solution that we're using for this titration experiment. H equal to 1, C equal to 12, O equal to 16, Na equal to 23, Cl equal to 35.5. Close your brackets. So that is the question that we have here. It's a highly likely exam question also when considering the concept of percentage purity. So let us see how we handle this question. Remember, if you look at the data provided, we've been given the average volume of solution A required. Take a look at that part of the question that said 25 cm3 portions of B required an average of 22.65 cm3 of A. So this particular question is alternative to practical. You are not to run the real life experiment for this particular question. You know in your exam, you might be given a real life experimental work. You might be given an alternative to practical. So this particular one is alternative to practical. That is why they have given us the average volume of solution A that was used. And the average volume is 22.65 cm3. So it's not a live practical. Are you following, right? It's an alternative to practical. Some of you who have taken your exams, think on Thursday and Friday, I'll be Friday, Saturday. I don't know, maybe you would have been tested on an alternative to practical in either salt analysis or in titration work. So let us bring out the data that we have here. Let's bring out the data. A is 0.100 mole per dm cube HCl. So that value given here is concentration of A, which is Ca, molarity of A, 0.100 mole per dm cube. All right, you know HCl is an acid, and then it's labeled as A. The question said that B contains 6.0 gram of a mixture of anhydrous, ANHYDROUS, that is dried. Are you following? Anhydrous, as used in chemistry, means a dried substance. B contains 6.0 gram of a mixture of anhydrous sodium carbonate and sodium chloride in 1 dm cube. What is the meaning of that given? Now, a certain mass is contained in a certain volume. The mass there is 6.0 gram, and then it is contained in 1 dm cube of solution. Remember that in, I think, the previous live class where I taught the concept of determining molar mass of an unknown monoacidic base, we saw something like that where I explained that once you know the mass dissolved in a given volume, you can calculate the mass concentration using mass over volume. So we're going to do that, but take note that here in that 6.0 gram, we are told that that mass is a mixture of sodium carbonate and sodium chloride. So here we have impurity. It's an impure solution. So I'm going to write mass concentration. I will use the word total mass concentration. Total what? Mass concentration of sodium triacylcarbonate 4 plus sodium chloride, okay, is equal to, the mass given is 6.0, dissolved in 1 dm³. That is going to be 6 divided by 1. This 6 is in gram. This guy is in dm³ given. Let me just show the unit per dm³. Since this has been given, the volume is given in dm³, you don't need to multiply this by 1000. You don't need to multiply it by 1000. If you take your mind back, the one we treated in our previous class, I explained that you have to multiply by 1000 because the volume there was given in cm³. So in this case, it's given in dm³, in liter. So no need of converting. So no need of multiplying by 1000. This is equal to 6 gram per dm³. This is the total mass concentration, you know, where you have both a mixture of sodium carbonate and sodium chloride. This is what you have, 6 gram per dm³. The question went further to say that 25 cm³ portion of B is the base. B is the base. So volume of the base is equal to 25 cm³. Required an average of 22.65 cubic cm of A. So volume of A, which is the average volume or the tighter value, all right, average volume of acid used is 22.65 cubic cm. And then I think that's all. That's the information given, and we are asked to calculate the molarity of sodium triacylcarbonate 4. Calculate the molarity of sodium triacylcarbonate 4. Now, you know, when you are calculating molarity, there are several formulas there. There are about 3, like I mentioned in our last class. The question now is, which one would you use in this case? A student is expected to be able to determine, out of the molar concentration, molarity formula, which one do you use in a given problem. For this one, you notice that they gave us Ca. We know the molar concentration, the molarity of the acid. And once you know the molarity of the acid, you know the volume of the acid, you know the volume of the base, and you can write a chemical equation which would give you the number of moles, that is the mole ratio of acid to base. The formula that you use to calculate molarity in that case is simply your Carver formula, CAVA over CBVB equal to NA over NB. And that is what we're going to use here. But to do that, I need to write the balanced chemical reaction for this. So this is a reaction between HCl, this reaction equation, plus, out of these two guys, what is reacting actually with the HCl there is this sodium carbonate. Are you following? So whenever you're doing this, you have impurity. Are you getting me right? Yeah. The base being mixed with an impure substance, or it could be an acid being mixed with an impure substance. Please, in writing the chemical equation, you are interested in the basic parts. Like in this case, the sodium chloride will not be part of the reaction equation, so don't go punishing yourself on it. Sodium chloride. Oh no, this is going to be sodium carbonate that we use. The sodium chloride is not used for this reaction. So looking at this, what is going to happen here? This will split here. This guy will split here. Sodium will react with chlorine to give you sodium chloride. Let me indicate it here. Sodium chloride. Okay. And then this hydrogen will react with oxygen from this CO3 to give you water. H2O. Then finally, if one oxygen is removed from here, you'll be left with 2 oxygens. Combined with this carbon, we give you carbon dioxide. Are you following right? So this is what you're going to get. Now from the reaction equation, you see clearly that the number of moles of acid Na is equal to 1. Because this equation, okay, is this equation balanced? Is it balanced? We have to balance before we can be able to determine the Na and Nb. Good. So this equation is not balanced. We have 2 sodium here. We have 1 sodium in the product. So I'm going to write 2 here. This automatically makes chlorine to be 2 in the product. But if you look at the reactant, chlorine is 1. So I'm going to come here and then fix 2 here. And automatically, chlorine becomes 2 in the reactant and 2 in the product. Hydrogen is 2 in the reactant and 2 in the product. 2 in the reactant and 2 in the product. 2 in the reactant and 2 in the product. 2 in the reactant and 2 in the product. 2 in the reactant and 2 in the product. 2 in the reactant and 2 in the product. 2 in the reactant and 2 in the product. 2 in the reactant and 2 in the product. 2 in the reactant and 2 in the product. 2 in the reactant and 2 in the product. 2 in the reactant and 2 in the product. 2 in the reactant and 2 in the product. 2 in the reactant and 2 in the product. 2 in the reactant and 2 in the product. 2 in the reactant and 2 in the product. 2 in the reactant and 2 in the product. 2 in the reactant and 2 in the product. 2 in the reactant and 2 in the product. 2 in the reactant and 2 in the product. 2 in the reactant and 2 in the product. 2 in the reactant and 2 in the product. 2 in the reactant and 2 in the Oxygen is, okay, sodium is 2 in the product and 2 in the reactant. Carbon is 1 in the reactant and 1 in the product. Oxygen is 3 in the reactant, and you can see we have 1 oxygen here plus 2 oxygen here, making it 3. So this equation is balanced. Therefore, Na is equal to 2. And of course, this is the base. How many moles of the base do we have? Nb is equal to 1. So the mole ratio of acid to base is 2:1. And we are good to go. The first part of the question, we are asked to calculate the molarity of Na2CO3. Molarity of sodium carbonate, sodium triacylcarbonate 4. That molarity is Cb. We don't know. Are you following, right? Molarity, molar count, solubility, concentration in mole per dm cube. These 4 guys, they mean the same thing. For the base, it is Cb. If it is for the acid, it's going to be Ca. So with this, I am going to recall the formula CaVa because of the information, the data given to us, divided by CbVb equal to Na all over Nb. And then since I'm solving for Cb, I can decide to make Cb subject to the formula, cross multiply, and divide both sides by what is multiplying Cb. In this case, you have CaVa times Nb divided by Vb times Na. Substituting, our Cb is going to be equal to, all we have to do is to fix up the values given there. And what can you see clearly? Ca was given to us in the question to be 0.100. That is the same as 0.1. Are you following, right? So no need of punishing yourself fixing the 0. The last zeros after this decimal point, you know, they are insignificant. Multiply by volume of acid, title value given by the examiner already in the question to be 22.65. And then multiplying by number of moles of the base, which from here is 1. Divide this by volume of base. Volume of base is 25 times mole of acid. The stoichiometric mole of acid here is 2. So with this, you see clearly that our Cb is going to be equal to, all we have to do is to multiply this out. 0.1 times 22.65 times 1. Then divided by, the denominator is already 50. When you do this, this gave 0.0453. 0.0453. Usually as a standard, molarity is given in 3 decimals. So it's going to be 0.045. 0.045 mole per dm cube. So this is the solution to the first part of the question. If you have any question, please feel free to ask. And for you friends that have joined the class, do me a favor. What can you do here? Remember, there are many yet to take their Chem 107 exam, chemistry practicals. Are you following? And some may not have been aware of GMAETS 41. Yes, some may not have been aware. And you can help them. You can help them. Are you following, right? You can help them. Share the link to them. Share this link to your friends, to your classmates, to your departmental WhatsApp group, so that those who are interested in it can join. After this live section class, I'm going to be hosting Physics 107. Okay, that's physics practical class. There are some things I want to point to students. These courses are courses you go and grab your A easily and just, you know, get yourself prepared for all that courses with higher credit load course. Higher credit load, that's higher credit load or credit units. Okay, so let's help ourselves. Share the links to your friend. Invite them to join this class now. If you have any question, feel free to ask your question. We are still dealing with chemistry as it is, the practical, because I guess the exam stretches till there about Friday or Thursday of this week. All right, so many are yet to take this exam. And who knows, your question could be something on percentage purity or percentage impurity, as the case might be. Let's move on to the second part of the question. II. In the second part of the question, we are asked to calculate the mass concentration, mass conc of sodium triacylcarbonate 4 into 50 cm cube of solution, into 50 cm cube of solution B, into 50 cm cube of B. Yeah, we are asked to find the what? Mass concentration of sodium carbonate. Now, you know, in titration work, mass concentration majorly is obtained from that relationship that relates mass concentration to molarity and molar mass. But you can also get it from this stuff we did here, that is mass over volume. If the volume is in cm cube, you multiply by 1000. But in this case, we didn't multiply by 1000 because the volume is already in dm cube. And let me quickly point to this so that some of you here to take this exam will not make that mistake. I've always said this. Listen, in my physical class, I had already addressed this concern. Some students, this volume of acid and volume of base, since they are given in cm cube, they might go converting them to dm cube by dividing by 1000. That is a waste of time. You don't need to convert your VA and VB. The reason is because if you look at the formula, this is VA, this is VB under. The cm cube will take care of themselves. They will cancel out. So you need of converting to dm cube. If you divide this by 1000, divide this by 1000, you have not changed anything. You have only succeeded to waste your time in doing that. All right. Therefore, for volumes of acid and base, please don't punish yourself converting to dm cube. Solve with cm cube straight, since the unit will take care of each other. Now we move on. Mass concentration of this guy. I've told you there are two formulas you can use. The question now is, which one would you use? Are we going to use this mass concentration formula, which is mass over volume times 1000? Are you following? Are we going to use that? Or are we going to use that formula where we have molarity equal to mass concentration, or otherwise molar concentration equal to mass concentration divided by molar mass? Which one are we going to use? It's important for a student to be able to determine the main formula out of the two that will solve the mass concentration. Now, if you look at this, mass concentration of sodium carbonate, we cannot use this formula, which is mass of perhaps sodium carbonate 4 in that case, divided by volume of solution, let's say 250 times 1000. We can't use that formula. The reason is because we do not know the mass of sodium carbonate 4 that is dissolved in 250 cm cube of solution. It was not given to us. Take note that this mass given in the question, this 6 gram that was dissolved in 1 dm cube, that 6 gram is total mass of mixture. That is why I wrote total mass concentration of sodium carbonate and sodium chloride. So in this guy, mass of sodium carbonate and mass of sodium chloride, they are there. But what we are asked to find here is simply the mass, that is the mass concentration of sodium carbonate 4. Since we do not know the mass of only sodium carbonate 4 dissolved in this 250 cm cube, we cannot use this formula, mass over volume times 1000, to get this. Therefore, we are left with that formula that relates molarity to molar mass and mass concentration. This is what I mean. We shall use the formula molar concentration, or simply molarity of B equal to mass conc of B, mass concentration of B divided by molar mass of B. Good. Now, molarity of B, we know it already. Molarity of B, or molar conc of B, or concentration of B in mole per dm cube, or solubility of B, is equal to 0.045. So all I have to do is write, let's see the space we can use here. I'm going to squeeze this thing here. All right, so moving on, molarity of B we have is 0.045. So I'm going to write 0.045. Let's see, 0.045. Let me make sure that this part is showing on the screen. Good. Good. So we move 0.045. we are going to equate this to mass conc of B, which we don't know. Mass conc of B divided by molar mass of B. Molar mass of B, B is sodium triacylcarbonate 4. Yeah, although B is a mixture of sodium carbonate and sodium chloride. But the part that is actually reacting with HCl in this reaction is the sodium carbonate. I explained that already when I was writing out this reaction equation. Therefore, we are going to use the molar mass of sodium carbonate only. We're going to use the molar mass of what? Sodium carbonate only. And what is the molar mass of sodium carbonate? You can find that out. This is the compound. So it's going to be the relative atomic mass of sodium, which is 23. It was given in the question. Multiply it by 2 atoms. You get there about 46. Then add it to relative atomic mass of carbon, which is 12. Add it to 16 times 3. If you do that, you're going to get 106. 106. That is the molar mass of sodium triacylcarbonate 4. 106. Therefore, cross multiplying mass conc of B is now going to be equal to 0.045 times 106. So that the mass conc of B, that is mass conc of that sodium triacylcarbonate 4 in the question, will now be equal to, let's multiply this and see what we are going to get. 0.045. Then this is going to be multiplied by 106. So this is 4.77. This is equal to 4.77 gram per dm cube. You can decide to approximate 4.8 gram per dm cube. The choice is yours. This mass you are seeing here is the mass of pure sodium triacylcarbonate 4. Because this mass, if you look at the way we obtained it from a process which made use of volume of acid used during the titration. And you know something? Let me tell you this very important thing. If you have impurity, maybe acid was made to be impure during the titration process, or base was made to be impure, if you carry out titration reaction, what that neutralization does is to purify that guy. So anything you calculate following that VA something, that is average titer value or average titer value or average volume of acid used. Anything you calculate that has a link to that VA is considered to be of pure substance. For example, this molarity of B that I obtained here is molarity of pure sodium triacylcarbonate 4 because it made use of this VA. And if you notice, this value we obtained made use of this VA, we are still using that value to calculate the mass concentration of sodium carbonate, which simply means that this mass of sodium carbonate is the mass of pure sodium triacylcarbonate 4. And what is the implication, dear friend? Although we have solved this second part of the question, this is what we are looking for. But I want to now tell you something regarding this total mass concentration. Remember, this total mass concentration includes the mass of sodium carbonate and the mass of sodium chloride. We have obtained the mass of sodium carbonate alone inside this mixture, and that mass is 4.77. 4.77. Are you following, right? But this 4.77 is the mass of sodium carbonate in 1 dm cube. And 1 dm cube is 1000 cm cube. Please, we are not done with this question yet fully. I just found out, I just quickly thought that we are asked to calculate the mass concentration in 250. The one we obtained here is the mass concentration in 1 dm cube. That is 1000 cm cube, which is from here. Like in this total mixture, right? Out of this 6 gram per dm cube, sodium triacylcarbonate 4 alone inside that 1 dm cube is 4.77, which means with this guy you can get the mass concentration of sodium chloride alone. It's just simply 6 minus 4.77. 6, which is the total mass concentration of the impure solution, sodium carbonate and sodium chloride. Subtract this 4.77 from that 6. What you are going to get will now be the mass concentration of pure sodium chloride. But let's go back to our question here. We are to look for the mass concentration of sodium triacylcarbonate for in 250 cm cube of B. In what cm cube? 250. But what we obtain here is in 1000 cm cube. Because per 1 dm cube is equal to 1000 cm cube. So what we are going to do, since we know the mass concentration of sodium carbonate in 1000 cm cube, or otherwise 1 dm cube, we shall now convert this mass to the value that will be in 250 cm cube. And how do we do this? It's simple. From our calculation, 4.77 gram is in 1 dm cube. That 1 dm cube is 1000 cm cube. Is 1000 cm cube. Therefore, what mass is going to be in 250 cm cube? What mass is going to be in 250 cm cube? So this cm cube and cm cube will cancel out, cross multiply and solve for that mass. Therefore, it means that the mass conc, okay, let's solve for that m alone. This m is now the mass conc of sodium carbonate in 250 cm cube. So this is going to be m equal to 4.77 times 250, then divided by 1000. And that mass is going to be equal to, multiply this and divide by 1000. Let's see what we are going to get. Let me adjust this a bit because I just found out that some part isn't showing. Let's adjust a bit. Good. So I think it's better this way. All right. So I'm reaching out for the calculator. 4.77. We multiply this by 250 and then we divide by 1000. So this is going to be 1.1925. I'm going to approximate it to be 1.2. 1.1925. I am approximating it to 1.2 gram, right? 1.2 gram. So this is going to be 1.2 gram. This is the mass concentration in 250 cm cube. Therefore, mass conc of sodium carbonate in 250 cm cube of B is equal to 1.2 gram. You know, this idea of mass concentration, which the unit is gram per dm cube, is simply telling you the mass contained in a given volume. Per dm cube means in 1 dm cube. What mass do you have in 1 dm cube? And 1 dm cube is 1000 cm cube. So someone can ask you, okay, calculate the mass in any other volume, which is not 1000. That is what this question is based on. And we have actually obtained it to be 1.2 gram. So the idea is this. We have 4.77 gram in 1 dm cube, which is 1000 cm cube, which agrees with this total mass something here, that the quantity of this sodium carbonate inside this 6 gram is 4.77. But the quantity of that sodium carbonate inside 250 cm cube is not this 4.77, rather it is 1.2 gram. So you take a look at this. If you have any question, you can ask as we go to the last part of the question. I think in the last part of the question, we are asked to calculate percentage by mass of sodium chloride in the mixture. So take a look. If you have any question, you ask before we finalize this. And once we finalize, stick around. All right, stick around. Just going to take a moment and we'll kick off with what I want students to know about their Physics 107, that is physics practical, which of course I am very well aware kicked off today. All right, some departments are already in the examination hall taking that practical course. So for those that are yet to start taking, maybe let's say from tomorrow, you can learn something from the live session class on Physics 107. Like I said, it's going to kick off after this class. If you are yet to register, what do I mean by registering? If you are yet to subscribe, okay, to this channel, if you are yet to subscribe to this channel, please hit the subscription bell, then turn on the notification bell so that once I upload any content, you will be personally notified. And also so that once I start any live class, you will be notified and then you follow up. Are you following, right? Or if you do not turn on the notification bell, you will not be notified. Remember, subscription is free. Turning on notification bell is also free. But you can support GMAETS 41's growth so that we'll continue to give you the best. And how can you do that? Click on the Join tab just below this video, and you can select any of the GMAETS 41's package. I usually suggest that you go for the platinum or diamond level, please, so that you can get much more benefits too, okay, from this channel. That one is not entirely free, but it's still free in a way. Why? Because you are supporting a channel that you love on the basis of the fact that the channel is giving you what you need. Am I not trying? It's not easy for me. Yeah. I go through a whole lot of stress making this available online because these stuffs, I've also taught them in our physical class, which is only available to those registered with the GMAETS 41's tutorials and campus in UNIZIK. But you see, to reach out to a wider audience, I just don't leave these in the physical class. And even apart from that, in the physical class, after you are done, months ago, you've learned this concept, and now you're preparing for exam. Let's assume you are done with your physical tutorial. You might still need a kind of reminder. So you see, I go extra mile to still assist students further online from the comfort of your home. Therefore, you can give attention to supporting this channel. Like I said, click on the Join tab below this lesson or this video, and then you can support GMAETS 41 on any of the packages available there. Please take a look, because we'll have to wipe this part so that we can solve the last part of the question as we round off this. All right. So I want to believe you've been able to copy this from the board. Now, before I wipe this side so we can round off the question, I'd like us to go back to that third part of the question, III. In that III, we are asked to calculate the percentage by mass of sodium chloride in the mixture. This is the same as calculate the percentage purity of sodium chloride. It could be percentage impurity of sodium chloride, as the case might be, because the impure stuff here, what made this solution of the base impure is that sodium chloride. Are you following? So we can talk about, all right, calculate the percentage by mass of that sodium chloride as that of the impure substance. Are you following, right? Yeah. So what do we do? It's simple. Percentage by mass of anything, percentage purity, percentage impurity, is simply the mass of that guy, the mass of that substance, divided by the total mass, which is mass of mixture. The impure guy, here it is 6 grams, right? Then multiply by 100. That is how you calculate the percentage of any substance in a given solution. So since we are to calculate the percentage by mass of sodium chloride, all right, in this mixture, it is simply going to be mass of sodium chloride in this mixture divided by the total mass, which is this 6 gram, and then multiply by 100. That's the formula we're going to use. So take note of this 6 gram, because for us to calculate the mass of this sodium chloride, which will divide by this total mass, we are going to subtract this 4.77 gram per dm cube of sodium carbonate. We are going to subtract it from 6 gram. You see, this part of this question is what made this a bit messy. Yeah. What made it messy? Because normally, when we are done, in most kind of questions, when we are done solving for this, mass concentration of this substance or that substance, that's usually what examiners require of us. But you notice that in this case, after getting the mass concentration in 1000 cm cube or in 1 dm cube, you are asked to get the one in 250 cm cube. So we weren't allowed to stop at this point. You had to convert it to the one that will be in 250 cm cube. But again, look at the problem. For us to calculate the percentage by mass of sodium chloride, a student should be able to determine out of these two masses, this one and this one, which of them will he or she use to determine the mass of sodium chloride inside this mixture? Is it going to be this or is it going to be this? So you see how messy this question is, right? Yeah, but it's interesting. And from this analysis, I hope that you are learning something that is very vital. So this is what you should know. This calculation made here is per dm cube, not per 250, not per 250 cm cube. Because the question said that this total mass, 6 grams, the mixture of sodium carbonate and sodium chloride, 6 grams of it was contained in 1 dm cube. So this unit agrees with this. Both of them are in per dm cube per dm cube. Therefore, to get the mass of this sodium chloride, you are going to use this mass. Subtract this mass of sodium carbonate from this 6 grams. To get this mass of sodium chloride, which you now divide by total mass and multiply by 100. So you take note of this. This is not what we are going to use to get the mass of sodium chloride. I'm wiping this, having explained this concept. Okay, let me stop at this point, because this space should be enough for the third part of the question, third and last part. So we have to find the percentage. We write this percentage by mass of sodium chloride in the mixture. The formula is equal to mass of sodium chloride in the mixture divided by total mass of mixture. Then we multiply this by 100. So that is going to be the formula we use for this last part of the question. All right. Udochukwu, you are welcome to the class. You're welcome to the class. We are moving on. So since this is the formula, all we have to do is just get our mass of sodium chloride in the mixture, which I have explained already. So I can say, but mass of sodium chloride in the mixture is going to be equal to total mass of mixture minus mass of sodium carbonate. Mass of sodium chloride plus mass of sodium carbonate is equal to the total mass of the mixture. Therefore, mass of any one of those two substances is going to be equal to total mass minus mass of the other one. So this mass of sodium chloride in mixture, will now be equal to total mass is 6 grams per dm cube minus mass of sodium carbonate in that solution of 1000 cm cube or 1 dm cube is equal to 4.77. So you subtract this and let's see what we are going to get. So this is 6 minus 4.77. And of course, I got 1.23. 1.23. So I am going to write this 1.23 gram per dm cube. So this is the mass of sodium chloride only, which is the impurity. See, this thing I'm dealing with here is just like examiner asking you to calculate the percentage impurity The percentage what? Impurity. Is there another word or statement that an examiner can use for this question? Why? The sodium chloride is the impurity in that base solution. The base itself is sodium carbonate. So what I'm trying to do here is the same as calculating percentage impurity of B. So this is going to now be percentage by mass. I'll go back here and substitute percentage by mass of sodium chloride in mixture will now be equal to, say the formula, mass of sodium chloride in a mixture, which we obtain to be 1.23 divided by total mass, which is 6, then times 100. And this is going to give us, let's evaluate at 1.23. We are multiplying this by 100 and then dividing by 6. So this gives 20.5. 20.5%. This is the mass of, this is the percentage by mass of sodium chloride in this solution. This is the percentage by mass of sodium chloride in this solution. And like I said, this is the same as calculate the percentage impurity in B, in solution B. This is the same as it. So with this, we can also find the percentage purity. Percentage purity now is simply the percentage by mass of this sodium carbonate. Percentage purity is simply the percentage by mass of this sodium carbonate, not of this one, of this particular value, because this is the value in 1 dm cube solution, which agrees to that 6 gram per dm cube. If I do 100 minus 20.5, I think I should be getting there about 79 point something, right? 100 minus 20.5, 79.5. That 79.5% will actually be the percentage purity of this guy. That's what I feel. And I guess we can also use our normal percentage purity formula to confirm that 100 minus this will now give you the percentage purity of sodium carbonate. Remember, why I'm explaining all these things that your examiner has his choice or his choices. You see the way this question has been presented. The examiner could have asked you calculate the percentage purity of sodium carbonate. I know in that case, since you have gotten this particular sodium carbonate in 1 dm cube of solution, it's now going to be this mass divided by total mass, which is 6, and multiplied by 100. Like I said, I have just done 100 minus percentage impurity, because like I said, 20.5 is the percentage impurity, which is the same as percentage by mass of sodium chloride in that mixture. I've subtracted this from 100 and got 79.5%. That 79.5% is the percentage purity. Am I communicating? Which we can actually verify, from this case, can verify that 4.77 divided by 6 total mass. I hope this works out because that's what I'm expecting. Times 100. See, exactly 79.5. You can verify it yourself, like I said. We are done with all the questions we are asked to find. I'm just giving further information of other possible direction that the examiner could have gone to in asking you this question. Take note that the one we solved, the third part of question that said find percentage by mass of sodium chloride in the mixture, is actually percentage impurity, which you saw the way I solved it. This thing you are seeing here, mass of sodium chloride in mixture equal to total mass of mixture minus mass of sodium carbonate. This mass of sodium carbonate is the mass of pure sodium carbonate, because the main base in this solution B is sodium carbonate. So once you subtract the mass of pure sodium carbonate from the total mass, what is going to be left is mass of sodium chloride, which is the same as mass of impure substance, because the sodium chloride is what made this guy to be an impure base, impure solution B. So what we calculated here in percentage here is actually the percentage impurity for this question. So suppose your examiner now asks you calculate the percentage purity. What would you have done? You have two alternatives to use. If you go through this, like if we have the fourth part of question, say calculate the percentage purity. All you have to do is 100 minus this, and you will get 79.5%. Like I said, that's the percentage purity. But now let me ask you, which substance is the pure substance in this base? The pure substance is sodium carbonate, Na2CO3, which is why that is the guy that reacted with the acid. You saw it in the reaction equation. Therefore, instead of just doing 100 minus this to get 79.5%, you can use that formula that most of you already know for calculating percentage purity. And what's the formula? Mass of pure divided by total mass. I think some educators, even your lab technology, some of them use that denominator, this guy, to be mass of impure. But I don't like using this guy, that word, mass of impure, because someone will mistake it when you are actually given the mass of impure. Like here, the mass of impure is 1.23. I prefer that students get to know that this denominator is total mass of the mixture, which includes mass of pure plus mass of impure. Because the impure guy here is sodium chloride. The mass is this. While the pure guy is sodium carbonate, the mass of this. The mass is this. So this denominator is actually total mass of mixture. I don't like using that word, that statement, mass of impure. If I use it, see this formula, right? It will actually be mass of impure over mass of impure. Because this 1.23 is mass of impure, like I said. So I prefer teaching with this. So rather than going to do 100 minus 20.5 to get the percentage purity, which is the percentage of this sodium carbonate, you can use your normal percentage purity formula, which is equal to mass of pure divided by total mass times 100. And the question now is, what is the pure substance here, the pure part of this base? It is sodium carbonate. Now, what is that mass of sodium carbonate in 1000 cm cube or in 1 gm cube? It is 4.77. Pick your calculator, press 4.77 divided by total mass, which is 6, multiply by 100. You will still get that 79.5%. So, we have done justice to this question and how you handle percentage purity problem in your exam. In case you are given such question, I want to believe that you can be able to actually trash it. It's simple. It's 1 plus 1. In any direction your examiner pushes you to, you can actually use the knowledge of what you've learned here to deal with the question. I hope you've learned something good from this calculation. Like I said, if you have any question, you can use the comment box, drop your question there. Of course, I'll respond to you if I see it. To prioritize your comment, to make your comments easily seen by me so I can respond to it, you have to become a channel member, please. You have to become a channel member so that once you drop that question or whatever, it pops up. I will see it because usually that happens to our channel members. YouTube identifies them with certain stars, certain perks. And once I see it, I know, okay, this is a channel member, I can respond to it. But if you're not a channel member, it might take time for me to see your question and stuff like that. All the same, thank you all for subscribing. I really appreciate your wonderful comments you've left, your appreciation for the work that GMAETS 41 is doing. Be assured that I appreciate all of them. Is that okay? I do appreciate, and we'll continue to do our best. As you move on through your exam, the GMAETS 41 Total Non-Stop Action, TNA, is declared open. And I'll be doing my best to guide you friends all through the courses that I'm taking you as you sit for your exam. With excellence, A splashes, and first class in view. Like I've always said, that's the language that GMAETS 41 understands. Yes, the academic language that I understand. I'll be seeing you in the physics class soon. Like I said, subscribe, turn on the notification bell so that once that class pops up, boom, you will be notified so you can follow up. I wish you all the best in your examinations.